Okay, next we're going to discuss a plane sailing. This is probably not something you'll be tested on, but it's important to understand the progression of complexity when it comes to sailings. Plane sailings are the absolute simplest form of calculating your course and distance off of two coordinates. And as the name implies, it's just imagining as if you were on a two-dimensional plane. You're doing this entirely mathematically with no regard to the shape of the Earth. You're just saying, hey, if I put my two coordinates on a grid like you use in algebra, what would be the course and distance between them if I were to construct it as one large right triangle? Now I just need to find the hypotenuse and this angle right here. That's something, even off the top of your head, you can probably understand how to do. All you need is this leg and this leg. And with the Pythagorean theorem, you could then find this distance. And with a little bit of trigonometry, a tangent specifically, you would be able to find this angle, which would be your course angle. Nice and quick. So we can label the hypotenuse as distance and this angle as CA. However, the first step you have to remember is that this is not your latitude and this is not your longitude. This is your difference of latitude. This is your difference of longitude, because the equator could be all the way down here. The prime meridian could be, in this case, all the way over here. You're not working at the origin. You're not working at 0, 0. You're working offset from it some ways, so you need to calculate the difference between the two first. So here's our starting location, 15 degrees, 20 minutes north, 30 degree, or 030 degrees, 30 minutes west, and our destination is 11 degrees, 45 minutes north, 020 degrees, 15 minutes west. So step one to a plane sailing, and really to any sailing, is to find the difference of latitude. So we do that by taking, it's easier to place the larger number first, whether it's the destination or the departure point, as long as you remember which it is so that you can put the proper direction later. But always just put the larger number on top, which at this situation happens to be the departing location. 15 degrees, 20 minutes. And then your next one is 11 degrees, 45 minutes. Same sign here, meaning we subtract. Remember, if we're in the same hemisphere, we're both in the north, you subtract the two values. If we're both in the south, you subtract. If we're north and south, you add them together. In this case, they're both north. So we subtract the two, got to carry the one here. So we turn that into 80 because, 14, bring over 60 minutes. 80 minus 45 is 35 minutes. Now 14 minus 11 is 3. Sorry, I was thinking about something else. I've never actually thought about that. So in other sailings, you have to then convert this to minutes. I believe technically the proportions are still the same. So you might not necessarily have to do it in this case if you're using a calculator set in degrees, but we're just going to play it safe. Now, in this case, your difference of latitude is 3 degrees, 35 minutes to the south, it's not a direction, is 3 degrees, 35 minutes, but you want to convert that entirely to minutes so that we can just work with a single unit the whole time. It makes the math easier. It doesn't throw off the proportions. It just makes the math work better or work faster. So to convert this to minutes, you take your 3 degrees, 3 times 60 equal, you multiply any degree value by 60, you get its value in minutes. So 3 times 60 is 180, plus your 35, that gives you 215. So your difference of latitude is 215 minutes of latitude. Now what's your difference of longitude? See, again, let's start with the higher one. 030. I thought I set the other one as the higher, whatever. So 030 degrees, 30 minutes west, and 020 degrees, 15 minutes west. Do the same process, subtract the minutes, you get 15. Subtract the degrees, you get 10. Now you got to convert that over. So 10 times 60 is 600. 600 plus 15, you get 615 total minutes of longitude as your DLO. So now you have this leg, it's 615, and you have this leg, though it's a little crowded, but it's 215. So you can actually do your calculations. In most sailings, you have to find your course angle first, and then you can use that to get your distance. In a plain sailing, they're two completely separate formulas, so you can do it in whatever order you want. The distance is just the Pythagorean formula. It's just going to be distance squared is equal to difference of latitude squared plus difference of longitude squared. Bring that over, distance is equal to the square root of the two. That's nothing new. Where's my calculator? There we go. Okay. So we'll do that first. 215 squared, 615 squared. You add the two together. Square root of the answer. Get 651. So your distance, your total distance is 651 we'll round that to 5.5 minutes. Now what's a minute? We've already said a minute of latitude is 1 nautical mile. So a minute of distance, or a minute in this situation, is equivalent to a nautical mile. Now, you might be confused because longitude doesn't equate to nautical miles. That's the problem with plain sailings. A plain sailing doesn't take into account the fact that a minute of longitude changes its value depending on your latitude. That is why this is obsolete. I'm still teaching it to you so you kind of understand where we're coming from, but that's why you can't just do the Pythagorean formula. This is not actually accurate for this problem. It's close to accurate. It's probably accurate within 10, 20 miles, I would guess, but it's not perfect. Exempting that, we'll move on though. Next, you got to find your course angle. Well, if you remember SOHCAHTOA, we are looking for this angle. This is our opposite. This is our adjacent. So we can cross these two out and think about tangent. So tangent of CA is equal to our opposite, which is difference of longitude over our adjacent, which is difference of latitude. So now if we were to take these same two numbers, divide them, and do the tangent of that, we will get this angle here. So let's do that. 615 divided by 215. Forget, I haven't used this in a while. Tangent of the answer. Oh wait, tangent inverse. I'm sorry, I forgot that. For trigonometry, if you're trying to find the angle, you do the opposite. So inverse tangent of that gets you 70.7. So this angle here is 70.7. Remember, that's 70.7 degrees just here with no specific direction. You have to apply the direction. You have to find the direction yourself. So where are we headed in this problem? Well, here's 15 degrees, 30 minutes north. Here's 11 degrees, 45 minutes north. We're headed this way. So we're going southwest. And if you're ever confused, if you don't draw it out, if you just have the numbers, remember, our north starting number decreased. our west starting number decreased. So we know that if it's north going down, it's south. If it's west going down, it's east. So we know that we're going southeast, meaning we have to then draw out our diagram again. Plus CA, CN equals 360 minus CA, and pick which quadrant is relevant to us. It's southeast, so we have to take our course angle, subtract it from 180, minus 70.7. You get 109.3. So our true course to steer is 109.3 degrees true. And our true distance to travel is 651.5 nautical miles. So with the plain sailing, this is really the most simplistic, but in terms of effort, easiest, fastest way to find a course and distance. You can just take these two values, plug it through a little bit of math, and you can get the course and distance between them. But again, don't use this because this is not accurate within every latitude. If you went up to the North Pole, 90 degrees north, no longitude matters. It's all zero. It's all equally zero. So it wouldn't make any sense to put 45 degrees west if you were at 90 degrees north. It's a meaningless statement, and that's totally ignored within the context of a plain sailing. We will get to that in the next video, how to actually address that problem.